Hi, I'm Bill Armstrong with Fluid Handling. Today's video is about something called the point of zero pressure change. We know that an expansion tank has two basic functions in the system. One we're well aware of. It's to accept expansion as the fluid in the system heats up. The other, however, is less well understood. It's called the establishment of the point of zero pressure change. And what that means is the point at which the expansion tank is connected to the system. The pressure in the system will not change whether the pump is off or whether the pump is running. Let's just walk through our board here and we'll talk about how it's constructed, and then we'll do a little experiment. First of all, we have a TACO circulator circulating in this direction. We come up through a loop here, and we have a circuit setter or a TACO AccuFlow that will allow us to measure flow. We're not going to do that today. Pump around the outside. This valve that's partially closed represents our system pressure drop. We have an air separator with an air vent and an air vent at the other high point in the system. Pump down around the loop. We have two gauges here on the loop. We have one at the discharge of the pump and one at the suction of the pump. In addition, we have an expansion tank. And the expansion tank is installed in a way that I can, through valving, connect it to the suction side of the pump or the discharge side of the pump. And I have a gauge at the expansion tank. So that's the system we're going to be working with. And I'm going to run a little test here shortly, and we'll show you how the point of connection to the system really is a point of zero pressure change. Okay, now we're going to run the experiment. We've got the expansion tank connected to the suction side of the pump. So I want you to focus on this gauge. I'm going to start the pump, and if the point of zero pressure change theory is correct, that pressure setting will not change when I start the pump. Pump's going, you can see there's no change. Now I'm essentially connected to the suction side of the pump, so let's look at the suction gauge when I start the pump. Again, no change. Let's look at the discharge side. Let's look at that gauge. Okay, you can see there's a dramatic change. We went from 13 psi to 28 psi, so the pump's creating a pressure differential of 15 psi. Now, if the point of zero pressure change theory is correct, when I change this so that the expansion tank's connected to the discharge side of the pump, that will be a point of zero pressure change. So let's watch. I'm going to start. Let's look at this gauge. Start the pump. No change because that's right at the expansion tank. Let's look at the discharge side. It's hard for people to believe that when this pump is pumping right into that gauge, that won't change. But it didn't. I started the pump, and because the expansion tank is connected very close to that part of the system, no change there. Now let's look at the suction side. Let's look at this gauge here when I start the pump. I'm at 13 psi now, and I've gone into a slight vacuum. I've got a couple inches of vacuum. That's not something we want to see in a system because it might cause boiling of the fluid in the system, and it will cause our air vents not to vent air. In fact, we might suck air in. So I think you can see with this little experiment that the point of connection to the expansion tank will indeed affect the pressure readings throughout the system. So we've established that the point of connection of the expansion tank is indeed a point of zero pressure change, and it should always be on the suction side of the pump. There's one caveat that I want to make very clear. The point of zero pressure change is a little bit of an unfortunate nomenclature because some people assume that no matter what happens in the system, this pressure will never change. In reality, when the system heats up and the fluid expands, all the pressures will go up. But we still want the expansion tank connected on the suction side of the system, so we always ensure a positive pressure there, whether the pump is running or whether the pump is not, whether the fluid is warm, whether the fluid is cool, and so forth. So that completes this video. Thanks for watching.